In this video, we will compare histograms and box plots. These dot plots show the fictional wait time distributions for two online tutoring services labeled A and B. For example, this student sent a question to tutoring service A and waited 1 minute for a response. This student sent a question to tutoring service B and waited 50 minutes. Let's add the box plots. Recall that the box plot divides the data into 4 equal-sized groups called quartiles. The length of a quartile tells us how much variability there is in that. For example, for tutoring service A, I can tell that there is less variability in the first quartile, the data is less spread out, than the data in the third quartile. But all of the quartiles contain the same amount of data. In this case, there are 5 data points in each quartile. Here's the data in quartile 1, and here is the data in quartile 3. Each quartile contains 5 data points. Now let's make histograms by binning the data. In a histogram, every bin has the same width. But the bins contain different amounts of data, and this is sort of opposite of a box plot, where the quartiles do not have the same width, but each quartile contains the same amount of data. Now, we know that a histogram can be useful if we want to answer questions involving percentages, such as what percentage of the sample had to wait 20 minutes? Or at least 20 minutes. How many students using tutoring service B had to wait at least 20 minutes? Let's see, let's use the histogram first and figure out how many students waited 20 or more minutes. 1, 2, 3, 4, 5, and then this person, 6 people. So 6 out of the 23 is 26%. Now, can I answer this question using a box plot? Well, I can tell from the box plot that the third quartile is at 20. So I can see that 25% of the data would fall above the third quartile, or roughly 25%. This is because the third quartile mark at 20 could have additional data values equal to 20, either below it or above it. So we don't know exactly that 25% fall in the last quartile, but roughly that. Now we know from the histogram that 26% of the students waited 20 minutes or more, so our estimate from the box plot is pretty good in this case. Okay, now let's look at tutoring service A. In a StatCrunch histogram, as opposed to the program I'm using, I would just use the heights of the bins to determine the number of students in each bin. So for A, I need to know how many students are in the last 3 bins, and that would be 3 plus 2 plus 5. 10 students who waited 20 minutes or longer. 10 out of 23 is about 43%. Okay, now let's look at the box plot for A. I cannot get a close estimate for the percentage of students who have to wait 20 minutes or more using the box plot. Why is this? Well, this is because 20 falls within the third quartile. When a value falls within a quartile, it's impossible to know how much of the data lies above that value or how the data is distributed in the quartile. All I can say is that the percentage will be more than 25% and less than 50%. You know, I can tell it's between the length of 1 and 2 quartiles. Now, using the histogram, we already know that 43% of the students waited 20 minutes or more using tutoring service A. So this concludes our comparison of box plots and histograms.